I welcome all of you to this course, Fundamentals of Aerospace Propulsion, and if you look at it, is quite exciting and fascinating subject so far aerospace propulsion is concerned. And when you look at an open sky, whether during the night time or in the daytime, you will be wondering what really it contains. Am I right? All of you will be have a wonder how it is. If you look at a sky in the night time, particularly dark pitch night without any cloud, you will see that lot of stars will be twinkling at you. Whenever I see that, I remember a song, Twinkle Twinkle Little Star, how I wonder what you are, and that still is remaining in my mind from the childhood. And I hope and I am sure that lot of you will be having similar feeling to look at what it contains, why it is twinkling, how many stars will be there. Can anybody tell me how many stars will be there in the sky? There are 200 billion galaxies, right, according to the scientist estimation as of now. One galaxies will be containing something 300 billion stars, and we are in a galaxy known as Milky Way, and where sun is the one of the star. We support all our energy requirement, all the life in this solar system. And this, if you look at, always man has a desire to look at wonders and how it will understand the thing. And this is a revelation due to the development of science and technology. Don't think that this modern scientists have found out this. This was there in our scriptures also about very exactness of that. Like for example, people were thinking the whole universe is expanding, one day it will contract. That is nothing but your Big Bang theory. So, and that desire to know and other things which have made us to think about how to go about it, how to move about it. If you look at it, like today we are in the moon mission, India is having a very prestigious moon mission. How to move about it, how to go to a moon and see. And so also there are planetary missions of USA and USSR and China and several other countries. Now this has motivated in of late to look at how to have a better propulsive devices such that we can meet our requirements. And beside this, there are several other applications like satellites and others which will be helpful not only for the winning a war, but also for civilian applications. And beside this, you might be knowing, you might be wondering how one can really fly, because whenever I see in this beautiful campus of IIT Kanpur birds, I always feel how they fly. And this kind of questions comes to the mind of the ancestors from the time immemorial, that how does a bird fly? Can we not fly like a bird? And there are several stories. I will tell you a story what my grandmother had told me when I was a child. She told me that my great grandfather had attempted to fly like a bird. Whether it is a story or a reality, I do not know, but it was being placed on me as a reality. So, who was trying to strap a wing to his very arm made out of bamboo, but unfortunately he made an accident which was killed him in the process. That is why it became a story. And similar stories you may find in our mythology, starting from Hanuman to Jambuban and several others. There is another mythological story I would like to share with you, that is about Greek mythology. There are two persons, one is father Daedalus and his son Icarus, who were imprisoned in the Alexandria, the great king Munis, and they tried to escape from the jail, made a conspiracy, and by using the principle of the flying, and they made the wing made out of wax and feathers. You know, like Icarus, who is a young and enthusiastic, he did not listen to the advice of his father, and he flied, of course, to a very high height, and because of sun the waxes got melted and he dipped into the Mediterranean seas. As a result, he was being caught and put into jail. So, if you look at, there are several attempts, several things have been told, stories are being floating around, how many failures they have made, but still people have tried, and later on there is a what do you call, the Sir William Calais, who was made a basically a what do you call, mimic the flight of a kite, and made a what do you call, a glider, right, in 1804. And after 100 years, there was a person known as Wright brothers who made a epoch of flying an aircraft. We will be discussing more about Wright brothers achievements, and there starts the era of the aerospace propulsion. You might be knowing the story of Wright brothers and other things. Now, let us ask a question. What do you mean by propulsion? Can anybody tell me, like, what do you mean by propulsion? Propulsion is basically stems from a word known as propel. It is basically a verb. What it means? It means to propel, right? To propel means to make or cause a motion to an object or a body. And when we are trying to impart a motion to a body or object, what we need to do? We will have to apply a force. Is it possible that we can apply a force and start moving? Certainly no. It will be unbalanced force such that it will be overcoming the inertia, right, or a resistance, and it must be in a specified direction. Specified direction means for a particular direction, whether it will be forward or a backward or a sidewise. So, this definition clearly indicates the existence of a body and a force to drive or push a vehicle, and this motion will be in a preferred direction, the desert. For example, if I look at I walk, is it in a preferred direction? How I am walking? Is it I am applying a force or not? And if I am applying force, how it is acting on the body? So, these questions all of you will be knowing, but we will be discussing it just to make it more clear and have a feel for it. So, if you look at, these are basic principles, or what you call, we mean propulsion. Now, when you talk about propulsion, suppose the insect is moving, or a what you call, a snake is moving on the grass or a ground, or a fish is moving in the water. Will you call it as a propulsion, or will you call it something else? Naturally propulsion, but we never use those terms whenever it is moving very often. However, because it is related to the motion, it is related to applying a force which will make it the motion, right, in a particular direction. So, therefore, we call it as a propulsion. However, there are several devices which are like automobiles, train and ships, which are being to be propelled, and for that we need to have engines. Similarly, we will be looking at in this aerospace propulsion, the propulsive devices are aircraft, missiles and spacecraft, and several others one can think of, right. But we will be concentrating on this. Then question arises, what is the basic principle which will be governing the propulsion process. So, we know that one has to apply a force and it will cause a motion. Now, whenever it will cause a motion, then naturally laws of motion comes into picture. You must have studied all these things in high school, but do you have a feel for it? What is this laws? If I say what is first law, what is second law of motion and third law of motion, some of you may tell me what it is in words, but did you experience those things? That is more important, to have experience than mugging it up or remembering certain laws or applying it in mathematical sense. I will take an example what a child experience these laws or not. If you look at a child, maybe 2 years or 1.5 years child, will it be experience these laws of motion or not, right? But if they are experiencing, but whereas when we grow up we are not experiencing. I will give an example how they are experiencing. And you might have observed a child has kept a toy in one place. You will move around and come and see whether the toy is lying there or not in the same exactly same place. Let us say a baby or a child is playing with a car toy, and you will push the car in a particular direction such that it will move and reach, and you are catching a, let us say, ball. A lot of children like to play with the ball. Like he will be throwing to a ball to another person, another child will catch it, or sometimes the single child is not having way to play or interact. Nowadays it is the go of the wall. So, they will be what you call throwing the ball towards the wall and rebound it back and they catch it. So, what it indicates? That is they are experiencing all the 3 laws of motion. What are those? First law of motion. Can anybody tell me like what is the first law of motion? No, please tell me in words. Inertia is okay, right? That means a body will remain in the state of rest or of in uniform motion along a straight line unless it is acted upon by an unbalanced force. What is that unbalanced force? That means if it is there, I will apply a force, will it moving? It is not moving. I am applying a force, but if I will apply more force, then it is moving. That means a force which is acting is unbalanced force that will make a body to move. Now, how will relate this unbalanced force to the change in the motion? Something is changing in the motion, right? And in this case there is a friction which is occurring, there is a friction. So, whenever friction is there, this force whatever I am applying must overcome the frictional forces between the surface and the body, right. Now, then only it will motion, it will make a move or it will be in motion or motion is imparted to the body. Now, if you look at like what really changing whenever an unbalanced force being acted upon a body, what is being changed? There will be change in momentum. That means rate of change of momentum will be proportional to force. So, therefore, in that case that we call it as a second law of motion, and this momentum will be in the direction of the applied force or the unbalanced force, right. So, unbalanced force acting on the body produces an acceleration because there is a change in the momentum of the body. Mass can be changing or so also velocity, or both of them will be changing. But when we will consider the mass to be constant, then change in velocity with respect to time we call it as a acceleration, right. So, therefore, generally we consider the second law of motion in which unbalanced force is proportional to mass and acceleration of body is known as, it can be expressed is a mathematical formula which all of you know, F is equal to ma. F is the force, m is the mass of the body which is about to move, and a is the acceleration imparted to the body due to the unbalanced force, and the direction of this motion will be always along the unbalanced force, and force is a vector quantity that all of you know, right. So, therefore, this is the law of second law of motion. Then what is the third law of motion? Every action has an equal but opposite reaction. When you talk about this, every acting force, for an every acting force there is an equal but opposite reacting force. What is the meaning? Where these forces will be acting? Will it be acting in the same object or will it be acting in the different object? It will be certainly no. If it will be acting in the same object, therefore, there will not be any motion, it will be in equilibrium, right. When it is acting on the opposite, then there will be having motion, right. So, this is the third law of motion. So, as I told you, to impart a motion to vehicle, reacting force must be acting on the vehicle, that is very important, otherwise there will not be any motion. I will take an example, this is a cannon, right. Cannon will be like imparting a motion to a ball which is there due to the explosion inside the cannon. As a result, the acting force will be on the ball and reacting force on the cannon. Now, if you look at this cannon, it is made, the mass will be very, very high as compared to the ball mass. So, therefore, the opposite force which will be acting on a cannon will be very, very small. I remember that when I was in high school, I was in NCC, my instructor asked me to keep the butt of the gun, that is the 303 gun, you must have might be knowing, right, along with the body, but unfortunately I did not listen to his advice, and then I got a pain whenever I triggered the bullet and it came and hit my body, right, because it is moving. So, opposite reaction is there. Similarly, several other things one can think of, right. For example, like there is in the swimming pool, there will be a springboard on which you will try to push, and then you will be jumped and put into the swimming, what you call swimming pool. So, this is another example. The way we walk is also by the third law of motion, right. And in our scriptures, we talk about every action as a equal but opposite reaction, that is known as law of mass, law of what you call karma, right. So, that some of you may not be knowing what is that, right. Nowadays people are not worried about, but it is very important to look at that law of karma, which is similar to the law, third law of motion, right. And so, we will take a balloon which is in inflated one and it is in equilibrium because the pressure which is acting on this balloon which is in equilibrium with the atmosphere, right. But however, it is having higher pressure. You may think how it is happening, because it is an elastic medium, right. So, whenever it is in equilibrium and if I remove this stem or allow the air to move, what will happen? The air will be moving out of this balloon and there will be an acting force, acting force or the action force, and there will be a reacting force along with this direction. As a result, the balloon will move away from the same place. This is a typical experiment what people do at least it is there in the high school book, but nobody does experiment today, either in the high school or in the secondary school or even in engineering college. That is the fate of our education system, which is very bad. Now, if you look at, this is the basic principle by which the rocket engines being worked. So, I will show you a figure where the hot gases will be ejected out of the nozzle. As a result, it will impart a thrust, and which will be must be much higher than the weight, so that, and also the frictional forces, the drag, so that it will make a move. So, this is the basic principle of the rocket propulsion. Now, we will take this balloon and look at what will be the gas turbine propulsion. I will take an example. Now, before getting into that, I would like to ask you, we are talking about aerospace propulsion, but is there any occasion for us to think about life propulsion? That means we propel our life. You take a bath, from the bath to the death is a one journey in a particular direction. Any of you have wondered any time how I will propel my life, so that my life will be smooth and good, I can contribute, I can reach an excellent state? I do not think. Some of you might be thinking, or some of you may not be thinking, right, and that is the main objective of all education according to me, not that what we do. So, it is, I would urge you people to think about this important aspect of how to propelling a life, which is more important than your aerospace propulsion. Because of that, people do not know how to propel a life. All the problems what we are facing in the society is being caused because of not adhering to the principles of humanity. So, I do not want to get into that, but rather I will suggest that let us say that there is a balloon which is acted upon the pressure. In acting I have seen, and the pressure is released here, and whenever the stem is being opened, as a result it will be like a nozzle, it will moving. But what will happen after the air, all the pressurized air will be going out, then the balloon will be flat and it will not move at all. Suppose I will take this example and then or analogy, I will think of how I will make it a continuous. What is the way? Can anybody tell me? I want to make it to move. So, what is the way out? Make my balloon to be moving forever or as long as I wish. That means I need to supply the air continuously. How I can do that? I can think of maybe pushing some air. When I will say pushing some air, what I will have to do? I will have to think of using a compression, or you can think of using an air intake, right. But the compressor will be having some mechanical component, right. So, this component which will have a mechanical rotor, it will move and it will ingest the air into that. But whenever I am having this movement of the compression mechanical, I need to move it. How I will make it to move this compression? Because I will have to have another device which will give the power for the compressor blades to rotate such that air can come in, right. And for that I need a turbine, and when I need a turbine, right, but how this turbine will move? It cannot move of its own. So, naturally I will have to give some energy, because if I ask where does this force comes? It comes from the energy. Without energy, can I have a force? Certainly no, it is not possible, right. So, what I will have to do? I will have to use energy. Energy can be any source. It can be chemical energy, it can be nuclear energy, it can be solar energy, it can be any other form, as a matter of fact, right. Energy having different forms. So, naturally I will have to using some energy source, so that I can extract some mechanical work in the turbine and which will run the compression. So, for that I need to have a combustion chamber where I will be using some chemical energy for this example, and that itself, and if you look at is it a gas turbine, it is having how many components? One is air intake through which air will be entering into the chamber, and the compressor which will be sucking the air and also rising the pressure, and there is a combustion chamber which will give some amount of energy to sustain it. It will be expanded in a turbine, and this hot gas will be expanded in a nozzle further to give a thrust, and this comprises of your gas turbine engine. So, this is a balloon analogy what I call of a gas turbine engine. And if you look at whole these concepts having three components, as I told, that means the propulsion processes involved in propulsion are three. One is propelling force at the thrust, and other is motion caused due to the thrust, which is basically a flight dynamics or aerodynamics one can think of, and vehicle body are involved. Whenever we talk about body, the body is basically in a structural thing, so that will become under structural engineering. And then what we will be looking at propelling force, and it is the force which we will be trying to generate, and whenever we generate this force we need to use the energy. Now we will be thinking about how to use this energy for generating a torque or a thrust or a force such that it can make it to move. So, whole gamut of this aircraft propulsion or the aerospace propulsion is related to how to utilize this energy for generating thrust or a force for making it to move or imparting a motion to a vehicle. So, this is the part which we will be concentrating. That means, we will be looking at aerothermodynamics of the propulsion. So, with this we will be covering the subjects in a following manner. As I told you, let us look at typical gas turbine engine, which looks like a air intake, and this is the compressor, there is a combustion chamber which is quite looks to be complex, and the turbine which is having two stages. There are several blades involved, and this is having a nozzle. Keep in mind that I have not shown here an air intake through which air will be entering into this engine. Now, this is basically a gas turbine engines. So, as I told you that we will be looking at the whole kind of a aerospace propulsion, and which is aerothermodynamics of the propulsion or aerospace propulsion, which we will be covering in this course. And in this course we will be doing in this way, because in following way, because as I told that I will be starting with the introduction to propulsion, and basically I have already introduced you something, but I will be giving you overall view of the whole gamut of propulsion in a very nutshell, and then we will be concentrating only on the gas turbine engine and the rocket engines. For that we need to review the basics of thermodynamics, that is the review of the basic thermodynamics. Then we will be looking at what are the equations that governs, that is the conservation equation which we will be using, that is one dimensional isentropic flow, and whenever we talk about this flow it will be at a high velocity, and then there might be a chances of formation of shock. So, we will be discussing about normal shock, oblique shock, and then we will be moving into Rayleigh flow and Fano flow, and some of you might be knowing, but we will have to recapitulate, relook at it from the different angle. And as I told you that we will be mainly dealing with the chemical energy for our propulsion devices. So, therefore, we will be looking at elements of combustion. Till this portion of the course, which will be basically being covered to make you adept in the fundamentals which are required to delve into the aerospace propulsion. After this, we will be looking at derivation of the thrust equation, in which performance parameter both air breathing and non-air breathing engine will be covering, and then we will be looking at cycle analysis of air breathing engines, right. I will be talking about real cycle analysis, ideal cycle analysis, how we can use for the design of an aircraft or aero engines particularly, and then we will be looking at briefly about solid rocket engine, liquid rocket engines and hybrid engines per se. And for this there is we will be referring several books, and which I have just jotted down few of them. And for the aero engines we will be looking at this gas turbine propulsion published by NMA, and fundamental of combustion we will be looking at what you call by myself D.P. Mishra, and engineering thermodynamics we will be looking at some portion by the Senage 2000. Beside this we will be referring these books, Mechanics and Thermodynamics of the Propulsion by Heel and Peterson, and there is a very classic book, the Sutton GP and Bibla's rocket propulsion element, we will be using it, and beside this the aerodynamics of gas turbine rocket propulsion Oates. And all these books except the first one available in the library, and I hope that it will be you can use, you can refer any other book as a matter of fact. So, my suggestion would be you should try to have your own notes that will be useful for to cater to your needs. Now, we will be moving into the what you call history of propulsion. Question arises, why you will look at history? Because it is a very boring subject, at least to me it was a quite a boring subject to look at history. Am I right? Some of you may not be liking to look at history, although our mind always move to the past or it will be moving to the future, but it rarely remains in the present state. That is the nature of the mind, right? Am I right or wrong? So, always brooding about the past or imagining about the future, whether bad or good or ugly. So, there, but however we need to look at the history of the propulsion or history of any other things, just to look at what we can do such that we can act today for the better future. So, therefore, we need to look at the history of propulsion. I will just give you a bird's eye view of the history of propulsion. If some of you are interested, you can make a term paper on that. It is a very vast, but I will start with a very what you call a Alexandria scientist who was living in Alexandria in 150, his name is Hero, who designed a aerofoil in 150 BC before Christ, and he has come up with a device which is shown to be here. I think it looks little awkward to look at today, it is not that compact and then jazzy to look at, but still then it gives a very great principle. For example, it contains a bowl which is shown here, and this bowl contains water, and it is having a close with a lid, and from this lid there are upright tubes which goes to this kind of a chamber which is spherical in nature, hollow sphericals. And similarly, this is having another upright which is connected. Keep in mind that this hollow sphere is having a two nozzles which is opposite direction. Whenever this water is boiled, steam is being formed, and this is being boiled using a wood, by burning of wood. Earlier days wood was a major fuel, and in future I guess that will be the only fuel after maybe 50 or 100 years, because it is renewable in nature. So, therefore, this steam, whenever it will go through this and it will be ejected through this nozzle, it will give you a couple, and that is nothing but your reactive forces or reactive torques. So, that demonstrate the reactive thrust principles. If you look at 150 BC, people were not knowing what are the laws of motion, but they have devised this thing, they have come up with this idea. It is a marvelous idea when I think of. It may looks to be trivial today, but if you look at 150 BC, it was a great thing. What it says to us, so far history is concerned, that means you should not be bogged down by the principles which is not there, but however you can do the design, you can think of, that is the mind. In modern days, the people's mind is restricted and constricted by these laws which are being formalized. Newton's came in 17th century, but hero who was really hero, who found out that what is to be done, and this principle is being utilized later on for the development. Now, and I will just tell you a brief history very much, like this 900, around 900, the Chinese, and of course there is a controversy, Indians found out the black powder. What is the constituent of this black powder, which is also known as a gunpowder? Do you know? Which you use for your rockets and then for your bomb in Diwali festivals, right? And then they found out the way of attacking enemies or defending the enemies, discovery of fire arrow. Later on, around 1150 AD, the Chinese people made a rocket which is similar to our toy rocket if you look at history, right? But it was making an epoch, have an impact. Later on, these Mongols and other warrior groups in Arab countries and other things, Japanese, like samurais and other things, they learned those techniques. So also Indians, and it spread to the all the thing because it was driven by the winning a war. So if you look at today also, the arsenals and the all aerospace related things are being misused, abused by the armies and politicians, is very important to note. So therefore one has to worry about. Later on there are several other things which I am not talking about it. In 1760, the Tipu Sultan of Mysore, who fought 4 wars, right, and he won all 3 wars, created a havoc, but unfortunately he lost the 4th Mysore war to the Britishers and he was killed, and they were using a what you call missiles or the rockets. Basically he is the missile man, right, although we know in modern days the Abdul Kalam is the missile man, right, but Tipu Sultan and was the missile man of this country, who were having created lot of things, and the Britishers took their rocketry systems to the England. There is a person known as Congreve, right, who really made several investigation and tried to mimic this design and was successful. They used against Napoleon in 1812 and won the war against Napoleon Bonaparte. So what I am saying, this is that means the rocketry is started basically from India, and which we do not know, right. Then of course the 1719 John Barber England got a patent in gas turbine engine, which is a long time back, but it was not being used. Why it was not being used? He got a patent. Got patent means basically an idea which was put in his name so that other people cannot copy it, right. But why it was not coming up? But later on in 1851, Henry Gifford used a steam engine to have the first aircraft flight from the Paris to the Trapper at a kilometer of at a speed of 11 kilometer per hour. It was a very, very small, if I look at person can run in this 11 kilometer per hour, more than that even, right. A normal man can walk maybe 7 to 8 kilometer per hour. But what was the thing? I guess when I investigated, I found that there was a balloon in that which was making it to drift, and this engine, which was a very bulky, was not producing any thrust. That is my interpretation. Some of you may look at it. So therefore it is the wind which made the move, and it was floating only, So, that was my interpretation. So, it is very important to look at that. Now, having said this thing, and if you look at the steam engine at that time was very popular, right. I will tell you another thing, the subject thermodynamics, was really developed because of steam engine. That means the engineering need not to become after the science. That means if you are good enough in science, it does not guarantee you that good engineering should come up, right. So, engineering come first, or science of course is required for to have a good engineering, but it is not that way. So, in other words, what I would like to suggest, one should not be bogged down by the constraint of the development in science so far engineering is concerned. How you can develop engineering is concerned? Then there will be some ingredients with the minds of the people that make us to think. I will be discussing little later on. So, if you look at 1870, the George Brayton demonstrated Brayton cycle, which we will be discussing in this course very often, and using a reciprocating engine. Generally it is today, it is Brayton cycle is, whenever Brayton cycle being discussed, it is for the gas turbine engine, but it was started with a reciprocating engine. And as I told, there is a epoch making event by the Wright brothers, who really for the first time make an aircraft to fly in 1903, and that is the history being created, which uses the 12 horsepower engines. And 1909 Rutherford Genome used a rotary engine aircraft, right, and covered a great non-stop distance of 180 kilometers, created a world record for endurance flight because it was flying for a longer period of time. And if you look at, this is a turbo, like a kind, it is a quite a good event, and but I am always fascinated about the Ray Lorin, who invented two things so far aerospace propulsion is concerned, but he invented several other things. He was a very innovative person. So, in 1913 he patented the design of the ramjet engines, and I will tell you also how he talked about air breathing engine little later on, that is 1908. So, 1916 Auguste Retief suggested using exhaust power compression to improve the performance engine. That means he was the first person to introduce the turbocharger to the aircraft engines. And 1930 the Frank Whittle submitted his first patent on the jet engine. Generally the what you call Frank Whittle is known as the father of the gas turbine or the jet engines, am I right? But however, there is a person Owens who is really the father of the turbo jet engines, who made it in 1938. And whereas of course the Frank Whittle 1941 he found a turbojet engine to power an aircraft, right. But if you look at, most of you may not be knowing who is this Owens, right. So, I will be discussing about it. I will just look at what is the audacity of a person, scientist, one who designed this rocket sled, right, and it looks to be a very awkward and to our mind, but if you look at, he used a series of rockets attached to the sled, and he sat down a chair and fired the rocket, and it flew for some times. In the process he lost his life. What a great sacrifice he has made for us to think about. Today we are very much frightened, and we are suffering from the fear, right, and which is being circulated by these market forces. So, therefore, and I am always fascinated about another person who is a visionary, who is basically an artist. He was not a scientist, but the kind of imagination he was having, it is much higher than a modern engineer can think of. So, what I will say, I will stop over here, we will discuss in the next class, that is tomorrow, which will have a media lab, right. Okay, thank you.